Okay guys, Marshall D teach here, and we are going to be continuing from where we stopped. So now we are going to start solving for the Laplace transform of sine 80 or whatever you call it, sine 80, whatever, I don't care. So firstly, there's something I want to let us know. According to Euler's formula or from complex numbers as well, these two things are equivalent. Saying sine of I theta is equivalent to saying sine of theta. Are we understanding? That's multiplying this by an imaginary number by square root of -1 is basically saying sine of theta, right? So now that takes us back. That is going to take us back to what did we say was the sine of theta before. We have to go and pull back our formula. Okay, from what I have here, we are solving with, in this case we are solving with 80. So what we actually have is sine of I80 is equal to sine of 80, right? That is what we have. So what we had before as our sine of 80 was sine 80 before was e to the I80 minus e to the negative I80 all over 2i. So that is where we are going to start our derivation from. If sine of 80 is equal to sine I80, it means all you have to do is anywhere where you see 80, multiply it by another I. Multiply it by another I here in this formula. So all you have to do, since this is sine of 80, sine of I80 is going to be what? It's just basically here in this power, multiply another I here. In this power, multiply another I here. I appear down here, multiply another I here. Are we following? So let's go. And that is how we are going to have, if sine of 80 is equal to the sine of I80 or stroke sine of 80 is going to be equal to what? E to the power of I times I80 minus e to the power of I times negative I80 all over what? 2i times I. Are we following? It's quite simple. Let's move forward. So what do we have at this point? We are going to have sine of 80 or sine of I80. They are both the same thing. It's going to give us what? E, that's square root of -1 times square root of -1 is going to give you what? The square root is going to come out, so you're going to just have -1, right? So this is going to give us e to the power of negative 80 minus, so this would have been e to the power of negative 80 as well, but there's an extra negative again. So this time around we are going to have e to the power of 80 all over what? 2 square root of -1 times square root of -1 is -1 all over -2, right? So this is what we are having, and we are not going to leave it like this just so it will look very good in the eye, right? Just so it will look very good in the eye. This is what we are going to have instead. We are going to say sine of 80 is equal to, if you take the negative from here upwards, what is going to happen? This one will become positive and this one will become negative. So this is our answer. Now we can now start finding the Laplace of this. Right? Now this is how it's going to happen. So we can now say Laplace of sine 80 or sine 80 is equal to what? You say integral from 0 to infinity of e power minus st dot what? Sine AT dt, right? That is what we have. Let's move forward. Okay, so continue from where we stopped. What are we going to have next? What are we going to have next? So we can now say Laplace of sine AT is equal to what? What is it going to be equal to? We are going to carry this and dump inside here. We are going to carry this and dump inside here. Let me write it clearly down here so we can work with it easily. Then I can now clean it from here. So looking at this now, what are we going to have? If we carry this and dump inside here in place of sine 80, see how we are going to simplify it. First, we are going to bring 1 over 2 out of the entire integral. We are going to bring 1 over 2 out. Then the first integral is going to be from 0 to infinity, of course, e to the negative st dot what? E to the power of what? 80, right? dt. That is what we are going to have. Minus integral of e to the negative st. Don't forget your 0 to infinity, right? Dot what? E to the power of negative 80 dt. Right? So that is what we are going to have. So by the time we are done solving this thing, what are we going to have? This is going to be our final answer. I'm going to skip all the steps because we have already solved these particular types of steps in previous videos. We've already solved this type of steps in the video for sine and in the video for cos. Trust me, it is not far-fetched. How I just went from this to this, it is not far-fetched. Just go back to the previous video and you understand exactly how I solved and got this. Are we following? Correct. And then in similar fashion, Laplace, so let's put it there. A over what? S squared minus A squared. Now, in similar fashion, what is going to be the Laplace of cos 80? If you just use your regular IQ, since here, sine of 80 is A over S squared plus A squared, and cos of 80 is S over S squared plus A squared. Then sine of 80 becomes A over S squared minus A squared, right? So cos of 80, if you just use regular IQ, you find out that it will probably look like this, which it actually is S over S squared minus A squared. So this is basically how we have sine and cos. If you don't understand this, please refer back to just one video before this one. Everything is explained there. You understand how we usually differentiate something like this. You find out how we break it down. It's in the previous video. So that's it. S over what? S squared minus A squared. Thank you. So now the next thing we are going to do is we are going to find out how to take the Laplace of t power n. Of t power n. Stay tuned. Okay, so now we are about to tackle the last one, which is Laplace transform of t power n. We have already seen the patterns. Now to attack the last one, the Laplace transform of t power n, we have to remember what the basic expression is, right? So the basic Laplace transform expression is this: Laplace of t power n, that's in this scenario, is going to be integral from 0 to infinity e to the negative st times what? T power n dt, right? So this is what we are having. Now, if you want to break this down, engineering students, you're going to see a pattern here. The technique we use to break this down is something called the Yale substitution method. You're going to treat this Yale substitution method in your basic integration. Most engineering schools do it in their 100 level, the Yale substitution method for integration. So here, what are we going to say? We are going to say U is equal to ST. Let U be equal to ST. Let U be equal to ST. So we can substitute it here. So what are we then going to have? the Laplace transform becomes e to the negative u. Did you guys notice what happened there? E to the negative u, right? E to the negative u times what? So if u is equal to st, what would t be equal to? We are also going to substitute it here. If u is equal to st, what is t? T is equal to u over s. So here we have u over s all power n. U over s all power n, right? Then dt. But this time around, since t is equal to u over s, we are going to say du over s, right? This is what we are going to have. This is what we are going to be having. So we can then comfortably say 0 to infinity e to the negative u, and then u power n all over what? This is now going to be du. All over, this is basically s power n, right? All over s power n dot what? S power what? This one does not have any power on it, so this is s power 1. This is what we are having at this point. This is what we are having at this point. This is what we are having. Let's move forward. Okay, so what is the next thing we are going to do? The next thing we are going to do is this. We have to bring this out now as a constant. Because of we are integrating with respect to u, we don't need this s. We can treat s as a constant, right? So we are going to bring s out. 1 over s power n dot s power 1 is equal to what? Sorry, not equal to, integral of what? From 0 to infinity e power negative u times u power n du. So when we observe this, you will notice a pattern here. Also, if you went deep into your integration, you're going to find out that this expression is called the gamma function. It's called the gamma function. This expression is called the gamma function. And when you meet the gamma function, is equivalent to here, whatever this is, factorial. So this now is equivalent to n factorial. This is equivalent to n factorial. You can go do your deeper research if you want to understand this more. So this now is equivalent to saying n factorial. So what do we have outside here? This is basically the same from your indices. You can remember that this is s power n plus 1, right? You're just going to add the powers. And then this is what? The gamma function, which gives you n factorial. So in the end, all you're going to have becomes this. The Laplace of t power n is going to be n factorial all over s power n plus 1. And that is your final answer. It's extremely simple. Let's add it here. N factorial all over s power n plus 1. And so that is it. That is it. The next thing we are going to be doing now, we are going to be going into proper calculations in Laplace transform. We are going to take examples here before we dive deeper into Laplace transform. Catch you guys later.